In the previous sections, we took logarithmic statements that were in the condensed form and we expanded them. In this section, we're going to do the opposite. We're going to take logarithmic expressions that are in the expanded form and write them into a condensed form. So remember our three rules, and I'm going to go all the way back to the beginning to remember our three rules, is that if we have logarithms with the same base and we're adding, we could change it into multiplication. If we have logarithms with the same base and we're subtracting them, we can turn it into a division problem. And then remember the rule that if we have an exponent, we could just make that into a coefficient, or if we have a coefficient in front of a logarithm, we can make that into an exponent. So going all the way back to our problems, we have this log base 6 of 3 plus log base 6 of 72. Notice we have two log base 6s, so that means we can multiply because there's an addition. And so in our calculators, we can just take that 3 times 72, and that should be 216, which it is. All right, so we can rewrite this as log base 6 of 216. And then we should try to evaluate that if at all possible. All right, so let's set that equal to x. We know that this is going to be the same thing as saying 216 equals 6 to the x. Okay, so remember, logarithm is an exponent, 6 is the base. And then in our calculators, we might just try to see what the powers of 6 are. All right, so we certainly know 6 squared is 36. What about 6 cubed? Well, that's 216. Okay, that's precisely what we were hoping for. Is that it's a power of or power with base 6. So we have 6 to the third equals 6 to the x, which implies all of this is going to be 3. A secondary example, log base 8 of 128, log base 8 of 2, and then we have this natural log. Okay, so there's two separate things going on here, two separate operations. But let's start with the log base 8. And notice we have a subtraction. So we're going to divide. So this turns into log base 8 of 128 divided by 2, which should be 64. But of course, we should always check just to make sure. So that's 128 divided by 2. And that indeed gives us 64. Okay, so this is log base 8 of 64. And then we can use that rule where we take the exponent and move it in front. So this is 2 parenthesis 3. That should be a 3, apologies, times ln of e. All right, so now what we should probably do is maybe evaluate anything possible. All right, let's set this equal to x. Okay, so log 8 of 64 is equal to x, or 64 equals 8 base 8 to the x. And we know that 8 squared is 64. And so that means that x is going to be equal to 2. All right, so this expression just turns into 2. 2 times 3 we know is 6. The ln of e just turns into 1. Okay, so remember ln's and e's are opposites of one another. So we end up with 2 plus 6 times 1, since ln of e is 1, and that ends up being 8. There are some times where we're not going to get a numerical answer. So for this example, 2 log of 6, or sorry, 2 log of 2x, log base 2 of 3. What we always want to do first is any coefficients, let's make them exponents. So we're going to rewrite this as log base 2 of x squared plus log base 2 of 3. And then notice we have the same logarithm, base 2, and an addition sign. So we're going to go ahead and make that into a multiplication. And so we can write this as log base 2. We usually put the numerical coefficients first of 3x squared. All right, that's probably as simplistic as we can make that statement. Sometimes we have to distribute to start. Okay, so let's take this -4 and let's start by distributing that to all of these terms. And so that's going to turn into the natural log of z minus 4 ln of z plus 2 minus 4 ln of z minus 2. At this point, we're going to make anything that, or we're going to go ahead and put these as exponents. So this is going to be natural log of z minus ln of z plus 2 to the fourth minus ln of z minus 2 to the fourth. And anything that has a positive coefficient is going to stay in the numerator. Anything that has a negative coefficient is going to go in the denominator. And so for our answer, we can write this as ln. Z is positive, it's going to go in the numerator. In the denominator, we have the z plus 2 to the fourth, just because it has a negative coefficient. And then we have the z minus 2 to the fourth. All right. Sorry about that. Marker scraped a little bit. So z minus 2 to the 4. All right. And that's going to be our answer for this. All right. That's probably as simplistic as we can make it. I'm certain that we could expand that if we really wanted to, but we have better things to do with our time than try to FOIL out that denominator. Okay. One last example before we conclude this video. We have 3 log base 4 of x, 2 log base 4 of y, minus 5 log base 4 of z. So again, what we should do is take care of any distribution. There is none. Next thing we're going to do is move all of the coefficients as exponents. So we have log 4x cubed, log 4 of y squared, minus log 4 of z to the fifth. Anything that has a positive goes in the numerator as a coefficient. Anything that has a negative is going to go in the denominator. They all have log base 4. And so for our answer, we're going to have log of x cubed y squared, because they're both positive. And then the negative puts that z to the fifth in the denominator. Right? So that's how we can go through and try to write these elongated sorts of logarithms into singular sorts of expressions that are condensed. Now, we still have a few more of these to do, which we'll do in the next video. And then the last thing that we have to look at in this section is the change of base formula.